say you have a system. This is a system that you have some force and moments acting on. Let's say force 1, force 2, force 3, force n, could be any n number of arbitrary number of forces, and also moments, a couple moments, m1, m2. Remember we showed couple moments with a curved arrow, so that means the rotation. This is the effect of force, push and pull. This is just simply rotation. And dot 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 and m n. So you have n number of force and moment arbitrary on the system, acting at various positions of system. For example, in this case of three-dimensional pipe, bent pipe, as you can see, we have two forces, F1 and F2, that are acting on this system. If we consider the entire pipe, that segment as a system, then the effect from external surrounding is the force acting this point, force acting this point. This could be coming from anything. This can be coming from the connector that we connect this to the wall, right? So this has some weight, so the connector will apply some force in order to keep it from falling off, right? And this can be coming from a cable or anything that is connected to the bent pipe. So this is the external reaction, the forces, right? Now let's consider this is our system. It can be a pipe or beam or a structure or this entire building, anything. Doesn't matter, it's a system, a mechanical system. And these are the force and moment on this. We can simplify, this is simplification, we can simplify all these things by replacing all these things with a single force, which is the resultant force. Now you know how to compute resultant. We have examples for that. With the resultant force and a resultant moment about that point. Both of them now you know how to compute. So you go to that point, whatever point I give you, you go there, you find the resultant force and the resultant moment of all of those. So if you replace this with the resultant force and resultant moment, you no longer need this guy. You get rid of them because it's simplified. See, you get rid of this complexity. At the end of the day, you have one single force, one single moment vector. Not value, the vector. One single vector, 3D vector for force, one single 3D vector for moment. At that point, O. Now if I change the point, let's say bring the point here. Let's change the point. O is now here. And do the procedure again. Look, the resultant force is going to be exactly the same. Why? Because force was independent of reference point. Force is such a universal abstract value. But the moment depends on the reference point. If I change the reference point, my resultant moment will be another vector. M resultant, call it 2, right? Then you can move that and put it there. Doesn't matter. But your resultant moment may change, but the resultant force does not change. It's the same. Example. We already solved it halfway. Three-dimensional example. They give you this pipe and they say replace the loading on this pipe on the system with just one single force, one single moment at point O. So what should I write for the force? Let's put the resultant here. So I put one resultant force, F resultant, and one resultant moment, M resultant. So what's the value of F resultant? Negative 60 plus 80, 20i, and
8J.
8J. Thank you. Plus negative 10 K. Right? So this is your resultant force. What's the resultant moment? You need to compute the resultant moment of these forces with respect to that. And you have two methods, cross product or moving forces. We have already done that. So what was the resultant moment we computed?
30I.
Yeah, it's 30I
Minus 40J.
minus 40J,
Plus 60K.
thank you, plus 60K. Now you can safely get rid of all this complexity because we do what? Simplification. So you can get rid of this and all these components. And you can get rid of this guy and all these components. You see? Now these two systems are exactly equal, mathematically speaking. They are exactly equivalent to both systems. So instead of analyzing that example, there you have two three-dimensional forces. Then you end up with two vectors, which is one force, one moment, right? In this case, it's not a big simplification because what we had was two forces, right? We end up with two. But let's say we have 10 forces and 11 moments. Then at the end, I have one force and one moment. So I simplify 21 parameters to 2 parameters. So that's a very useful example, very useful tool in order to help us to be able to understand the physics. So let's go to consider one more example. So let's go to page 123. Three, 4, 5. So 3, 4, 5, 6. This one. 0.3 meters. All right. So now a system is given that we have three forces acting on it. And the question is asking simplify these three forces with just one resultant force and one resultant moment about point O. Alright? So you know what to do. Find the resultant force, put it here. Find the resultant moment with respect to O, put it here, and get rid of the rest of it. Because at the end of the day, they are equivalent mathematically. So what's the value of resultant force?